If you seen here, I have a picture of a circuit here. Is there a way of my placing it on top of that? Yes. If I see the, I need to open this probably in Paint, and cut off and make it look as close as we can to a I have cropped it. I have a beautiful object which has been cropped. I am going to save it as just PC. Now comes a little bit of what do you call, I will say, see, I have a bitmap which I can use it for whatever purposes is it. This I will now try to take here and see what best I can do with it. I will now create a plane on top of it, try to put this printed circuit board on top of it and see how well it sits here. Oh, let me see the orientation. Yes, orientation is this is long that side, and in this case, yeah. To me to simulate a small printed circuit board inside, again go to the original drawing here, and then I try to unhide all those things in case I have them, and then I will try to make a simple surface, a plane, move the plane up, and you see this is where going to be a little very interesting thing. Any software package, you will have the option of giving things a texture and giving things a what do you call real feel and all that. So, I now go for this what do you call giving this object property. I will select this, I will go for the basic material, I go for the basic thing, and then go here for the whether I can have a texture map. Right now I have this texture map built into it in this computer. It has been attached to this now. But now you see when I try to give a rendering, you see what will happen. There my printed circuit board is nicely sitting on top of it. So, I have a double advantage for me, whatever I have started, it is now very much easy for me to check whether things are mating or not. Similarly, since this has been made with some material, so I will see if I can give, in this case all the material is made of the same thing here. Now I will see whether I will try to give a basic material here, and then I will see whether I can give similarly a basic color, and maybe my print is going to be a dark blue box, and then say OK, and then now when I try to give a rendering, you see here I have a blue box on which there is a nice printed circuit board which is sitting there. I can go on like this and then try to build more and more and more things on this. So, what I will do is I will now try to lower this circuit down, not perfectly aligned. Okay. So, I probably need to remove this snap. Now it is slightly better, see, it is sitting nicely, and then I can probably even lower it a little, I will lower it a little, and now for practical purposes this is how my final unit is going to look like. Oh. Done. This is what actually 3D printing is all about. Now, one more item I have what you call intentionally left off for you is, do I now put a heat sink on top of it? Yes. If you see, they remember the whole thing inside. Now, I have these 4 connections here. I have to decide whether I give a relief on the heat sink, and then I have these 2 mounting holes. Now, I can use the heat sink, and in this case, no, this is where the via holes are there, and the manufacturer has recommended that we use the via holes, put a little bit of heat sink paste and just clamp it down with sufficient force. So, for me to do that, I need to create the what you call heat sink plate on top of it, and to make use of the extra area is available here, I am going to make a simple rectangular plate all along, and then I am going to have these 2 holes, and then we just need to clamp it. Except that you will notice is still we have these 4 corners which are likely to create a problem for us. See this, no, those 4 corners are likely to create a problem for us. So, when I try to create a heat sink for this, I will continue to use this, there is no problem about it, it is the same plane. You have seen this, no, same plane, I can try to make a heat sink out of it. Except that my box, if you see, I make a box now, I make a plane which starts from corner to corner. I have one corner here, I have a corner here, and then I have my and the 2 things which I am going to what do you call make use of in my design, they are almost coplanar, both of them are sitting in the same plane. Why it is useful for me to make use of it is, I come here now, I will make use of this 4 corners and see how best to avoid that shorting in the corners. So, one easy way is, because we have a notching facility, it is very convenient for us to make a notch here. All we need to do is make another one more what do you call rectangle. I will go a little faster. See, that much of a notch I need to give, so that the heat sink does not short. So, I will now copy this to the, like before, I mirror this, and at this point I, because the easiest for me now is take this, again take these 2, mirror it again. See here, I am getting better at, I will now go here and try to what do you call cut these surfaces completely. I select all these objects which I can use for notching off. Notch, corner, 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 corner. You see here, I have a nice heat sink where the corners are beautifully taken care of, and if I switch on the other layers at the bottom, even the mounting holes can be there. If you remember, one mounting hole was here and another mounting hole was here, and the whole thing there. So, what I will do is now I open this and try to and unlike they build up earlier, I can have the luxury of having a full drilled hole. Advantage of a drilled hole being, as always in the workshop, it is very easy to drill such things. See this, I now try to, now I need only this, yeah, and my outline. Oh, sorry, it is very much there, it is just that it is hiding, it has decided to hide itself underneath. So, most likely it is somewhere here. Oh, allow me to unhide everything and get back, it can't trick me. It is sitting here at the bottommost like this. See, that hole has got created at the bottommost layer, I mean the bottommost part of the thing which I am talking about. I probably need to move it. Come on layer, where are you? Finally, I got them here, now it can't escape. See here, I have this opening here, I have this opening here, and then I have what is part of the heat sink on top. So, I now try to do what I tried to do earlier. See, there is a, due to some technicality, it works best only as a, what do you call, Boolean operation, because for some reason these things do not, I cannot, what do you call, I cannot see the plane there. So, normal way of trimming does not seem to help. However, anyway, since eventually I need to convert it into a thick plate, I will make it into a 2 mm aluminum plate. Now, I will extrude the solid. I have a 2 mm aluminum plate, then I make a solid out of these curves and make openings by making a difference. Sorry, it has gone and picked the wrong thing. So, I will make a difference, again I will check. First set, yeah. Now, second set of poly holes, done, and then these two I hide, and this being a sheet metal, we cannot just leave it. Hey, what happened? How was bad luck? Oh, no, it is not a bad luck, it is a matter of when I developed that surface, no, that surface ended up with some problems. All right. Now, this being a sheet metal part, it invariably requires the filleting part. So, I will fillet this edge by, in fact, I will give a very generous fillet. So, if you kindly look at my that working monitor, a little bit of audio was lost, I will see what I can do. You will notice here that this object which I have tried to create, ended up with completely going off stage. You have seen this is supposed to be the heat sink. Due to some, I can't say whatever reason it is, it has not come out well. Now, I will try to reconstruct it by going here and seeing at best what best I can do with it. One of the easiest thing is probably to start with a polyline, and I will disable the OSNAP. I have got a reasonably, what do you call, well well defined I think probably input my diameter by hand. So, I have got a circle here. I will now copy this circle with respect to the center to the other point, and the other big object that I have created, I will delete it. I will come back to where I have started. The problem that happened was because I tried to do a chamfer and it did not come out well, and I ended up with a opening here. So, this time I will see whether I will create a different what you call solid with directly from these objects, and then I will try to extrude the planar curve. This is a 1 mm. I will make a 2 mm sheet here. Oh, sorry, bomb. Those circles were not in plane. So, I will now bring the circles back to plane. Much easier to do the Boolean operation. I try to extrude this into a solid, this plane, I am sorry, this curve I will make a solid out of solid, extrude planar curve straight. I have a 2 mm plate in which now I will try to remove this material by making a Boolean operation. So, when I make this Boolean operation, one of the first things that will happen is, since that I will have that nice holes which will take place very well. See, I have got this nice openings. Now, I will go back and what you call unhide the whole lot which I have here. Yes, in this here, this is where we were starting. Now, I just got a brainstorm when I went to follow up the other thing here, saying if we were building a heat sink on top here, we are building a heat sink on top here, why just leave it just for the what you call, why do we need to just open the sin that why do we need to just leave this for this, and why not I give a corner support here, so that anyway since material is there. So, I will just take this small thing up a little, make it flush, see I have got 2 more 1 mm slices which are built here. So, I will remove this from this material here. I will try to do a solid what you call Boolean difference here. From this ring object, I will see if I can remove this and what will remain about it. You see, I have a nice something which looks as if it is going to fit inside. So, it is going to look fine. And then just now I was again checking back with my what you call colleague downstairs. What he has suggested is that all this building up is amounting to too much of material and time. It says the build up may take about because of the resolution it may take almost an hour. So, why do not you remove all these materials. So, eventually I will probably have a very extremely simple object which I will try to recreate and show you later. Right now let me undo this. Yes, in this I need to copy one object, hide it, so that I continue to have it. Now, do the Boolean with these things. See, now you will notice that I do have the object what I wanted to create, and in this case they are also represents what you call the various layers, and then now I take this cover over, and the cover sits very comfortably here. And when I actually fire the job, when I go there, I will probably even remove I will remove all this what you call unwanted thing here, because he has assured me that all this much of support will really not help, except in what you call wasting a lot of material. So, eventually I am going to have something which sits, and then as I told you before, it's going to be fine. I'm going to have a beautiful unit, which the top portion is now going to be the heat sink which sits there. Then I also make a what I call counter sink or a counter bore, so that everything is flush, and in fact this is where a little bit of improvement can be done, saying once you have a heat sink and one you have a printed circuit board and all that, why do you need this 4 corners at all for anything? Why can't the unit be built directly onto the heat sink? You understand, no? And a cover can be placed over it. Imagine this whole thing. Sir, if you can show me this, please show me the main camera, sir. So, I can have the unit attached to a heat sink and put a small cover on that. This is going to be a simpler object in that. So, I have these 4 mounting holes, I put something for the cover and see how well I can attach the cover back to this. This is how actually happens when we have other objects there. See this, no? It sits quite comfortably. Okay. So, I mount it on a heat sink and then I put the cover on top of it. So, in this way I optimize, probably optimize the whole thing. I do not even need all these things like this. I can probably have a what you call a simple device which what you call sits, and after the wiring is over, I put the lid over top of it and then provide some other arrangement by which I make it clamp onto the printed circuit board. Now, you see here I have 2 more units which I have brought. Sir, can you put them onto the screen? Yeah. You see this? Oh, you see here. This is the one I am talking about. I will have this mounted onto the heat sink and I put a lid over it, and overall I have a beautiful project. And how do I put it on the heat sink? Just put a plate. I have these 2 small what you call openings. So, I will probably need to tap it and then put a screw from this side. So, it sits here and this will go and snap into the cover on that. You see that my design has been simplified. Now, take a look at this small thing which has been, while this has not been made by what do you say, rapid prototyping, specifically it has not been made by 3D printing. This is typically a fully sealed IP 60, probably 56 and 56 box maximum. Generally overall it is, and even here you notice there is a lot of attention has been made for making a groove all around here. There is a rubber gasket and a groove here, and as it is we may not be able to use it so much. That is the reality, and final assembly is probably going to look like this. What do we have here? We have 2 gland nuts. These gland nuts are separate pieces. Okay, this gland nut has a collet like thing here. I need to do something. When I tighten it, it will squeeze the cable and make sure that everything is, see here, I have a collet, I have a gland nut, and then I also have a strap. The strap goes in, I can use it for tying it to a tree or anything. And now, if you recollect yesterday, in one of the demonstrations, this was shown. Do you remember this? This whole thing was shown there. That was a standard demonstration. It is unlikely that people will ever make this, what do you call, things which are easily available onto make it in rapid prototyping, though you have a file, not I, because the whole thing is probably available for a few cents. A good quality one may be 50 cents, and a poor quality thing may be only 5 or 10 cents. And things which we cannot do are probably this sort of thing. There is a strength and transparent issue here. We have this thing has been, a head section has been made out of polypropylene, so that polycarbonate, so that you can bend it and you can put it inside like this. Now, slowly some of the machines will give you the same amount of what do you call thing here. So, allow me to stop here. Okay. Tomorrow modified variants of this I will try to load there on the machine and show you various ways of how this thing can be done, including, as I said, after talking everything, originally we just wanted to put it here and put a cover, and the moment this heat sink thing has come, and since we need to play with it, decided why can't we put it as it is here like this, mount it on the heat sink and put a cover. In case we do not have the heat sink, we just need only a what I call a insulated printed cover, or maybe we can even make it such that it is snap fit, like this goes into one part of the cover, and then if you have these two openings here, okay, those things, there is a small button, this will go and snap into that button. Once the whole thing snaps here, and then I bring the other part, okay, which those things nicely slide here, and then I have two things which are basically a very simple design and no support is required, and overall the amount of effort required in manufacturing will be very simple. So, I will see if I can what you call create the whole thing before the next what you call session, and then see how I can show you a simplified design. So, thank you. This section, no, this part of it on how to take a print, you understood, no? I have taken a scan, and then as best as possible I have tried to transfer all these items onto this, taking actual dimensions, and then I try to create a model by making use of this, and then this is how typically technical what you call 3D printing needs to be taken place. It is not just downloading a file and hoping things will work, very critical, otherwise things like this won't have happened. Very complicated piece, now it is you know available, same thing, not easy. Okay. So, thank you, we will continue with this in the next session. Thank you.